Welcome to the 6th video in our series explaining PS requirements. This chapter focuses on building a comprehensive data model for the document team. After we've discussed the client details, communication methods, design preferences, and templates, we will move on to demonstrate how to organize and present field information. We've already identified the main object from which we'll generate forms, as discussed in Chapter 4. For clarity, please also specify this main object at the top of your data model mapping table. The PS requirements form includes a blank table with columns for all the necessary information. We will fill it out as we go along. Document building blocks. As mentioned in the previous videos, documents and forms have several building blocks. Documents have a look and feel that includes a specific layout, color scheme, formatting, and branding. These elements were discussed earlier and are reflected in the template as demonstrated in video 5. Documents contain fixed text and other elements that will appear in all instances and scenarios in which this document will be generated. This text will also appear in the template. Documents also include dynamic text and other elements that will only appear under certain conditions and depend on data pulled from the Salesforce system or other sources. This dynamic text should also appear in the template, while the fields or data used for the conditions must be listed in the data model. Finally, we have the data itself, which is stored in different objects in the CRM. These objects are connected to each other through various relationships. All these fields, and any relevant information needed to locate and extract them, must be included in the data model mapping. Field types and sources. Let's review the different types of fields and their sources that we'll need to map in our data model. Understanding these field types is essential for properly organizing your document requirements. Fields can come from various sources: standard word fields, plain fields directly on the main object, formula fields, lookup fields, and fields from related lists. Each type requires specific handling in our data model. Let's look at some specific examples. The proposal date is one field we'll use in our document. This comes from Microsoft Word itself. It's a standard word field that automatically pulls the current date from your computer or network. Similarly, another useful word type field is the total page count, which dynamically shows how many pages are in your document. When filling out your data model table, be sure to identify these as word fields in the source column. Next, we will discuss fields from the system. The easiest fields to map are plain fields that appear on the main object from which the document will be generated. Let's take a look at our sample opportunity object in the system. Our document will be generated from here using one of these buttons. The opportunity object contains several types of fields. There are standard fields created by Salesforce, custom fields added by your organization, formula fields that calculate values, and fields that reference other objects. The fields we will need that appear on this user interface are opportunity name, brand total, close date, event date, location. Let's fill them in. For these fields located directly on the main object, the template uses the same names as the system, almost identical to the API names. This makes them particularly straightforward to map. Now let's look at a more complex type of field. The decision maker field is an example of a lookup field, a field that references information stored in another object. As you can see on screen, Sabrina's name is actually a link that connects to the contact object. What makes this particularly interesting is that when we look at the contact object, the name itself is not a single field but actually a compilation of 3 separate fields: salutation, first name, and last name. This is a common pattern in Salesforce where what appears as a single piece of information might actually be composed of multiple fields from different objects. To verify the names of the fields we are looking for, we can use the Salesforce Inspector, which is a Chrome extension available from the Chrome Web Store. This is the inspector that we use. There are newer versions available from the Chrome Web Store. Here, we can see salutation, first name, and last name. However, these names also appear in the background on our main object, the opportunity. Now, staying on our main opportunity object, Let's use the inspector again to examine how these fields are implemented. Looking at the background of our opportunity record, we can see that the decision maker first name and decision maker last name appear here in italics, which means they are formula fields pulling data from somewhere else. Hovering over the value while still on the opportunity object, we can see that it comes from decision maker, which is the API name and screen label of the same contact lookup we saw before. These formulas can be updated at different schedules. Using a formula field might produce a different value than using the value from the lookup. That's why it's so important that the client defines exactly where the values should be fetched from. In our case, we will take the decision maker from the formula field of the main object. Vendor information. Now let's move on to another type of field, lookup fields. These fields retrieve data from related objects through a lookup relationship. At the top of our template we see vendor information. The fields for name, email address, vendor phone, and website are highlighted in yellow. These fields aren't directly on our main opportunity object, but instead must be accessed through a lookup to the vendor object. Going back to the opportunity event object, we have a vendor lookup. Note that this time field names in the template are not identical to those in the system and were selected by the client to make them easier for him to remember. Let me show you how the field names differ between the template and the CRM. In the template, it's called vendor name, but in the CRM, it's the account name. The same pattern applies to the other fields. Vendor email address in the template corresponds to custom email address in the CRM. Vendor phone corresponds to just phone. Vendor website corresponds to simply website. This difference in naming is why mapping these fields correctly in our data model is so important. Now we need to document these fields in our data model table properly. When mapping vendor fields, we must create clear connections between the template names and their corresponding CRM labels. We'll add these vendor fields with their proper paths in our data model table. Since these fields come from the vendor lookup, which is an account type object in the CRM, we'll indicate this relationship by adding L in the path column, where L stands for lookup. You may have noticed that the template contains green comments about some fields. You have two options for handling these comments: either keep them in the template as they are, or transfer them to the notes column in your data model. Both approaches are valid, choose whichever works better for your documentation style. Client address. Let's examine another example of lookup fields, the client's address. Like the vendor information, these address details are accessed through the account lookup from our opportunity object. The client address combines 5 distinct billing fields from the account object: billing street, billing city, billing state, billing zip code, billing country. In the template, these are labeled as client street, client city, etc. Let's add them to the table and specify the path through the account lookup. L in bracket stands for lookup, and the path is through the account. If one of these fields is missing, we want to skip it and close the gap, so this is added in a comment. Related lists. Now we'll explore a more complex data structure, related lists. These represent a one-to-many relationship, where our main object, the opportunity, can be connected to multiple related records. Unlike lookup fields that retrieve single records in a one-to-one relationship, related lists contain multiple child records associated with our parent object. In our example, we have products the client wants to order. Our template displays these in 2 separate tables: essential items and extras. Each table shows product information in rows that will multiply based on how many products match specific criteria. Looking at the Salesforce interface, notice that this related list has 2 names. Opportunity product is the screen label, while opportunity line item is the API name. Both names appear in the title when using the inspector. The fields we need, product code, list price, sales price, and quantity, are available directly on this related list page. When adding these to our data model table, we'll mark them with R to indicate they come from a related list and include the API name opportunity line item in the path. Be very careful with the YL and R annotations, mixing them up can cause errors, especially when an object has both lookups and related lists with similar names. Now let's review the fields we just mapped. We want to display whole numbers only for the quantity field, so we'll specify masking with no decimal points in our data model. The field names in the template begin with the letter O, reminding the client that they come from the opportunity product object. Note that the API name of the sales price field is actually unit price. Without this bit of information, the documents team will have trouble locating it. The first line field needs to be added to our data model table, even though it won't appear in the final document. This field functions as a filter that determines which products go into which table. When first line is false, the product is displayed in the essential items table. When true, it goes into the extras table. Product information. Let's look at another example of a related list. The product name and description fields for each product are located in the product object. This object is accessible through a lookup relationship from the opportunity product object. We need to document this path clearly in our data model. Let's add them to our table. Remember that we're working with a one-to-many relationship between our main opportunity object and the products when documenting these fields. This relationship structure requires special handling in our data model, particularly regarding displaying multiple product records. When working with related lists, your data model mapping must specify exactly how to handle multiple records. There are several possible approaches. You might need to include all records without filtering. You might need to filter records based on a condition, as in our example where we use the first line field to determine which products go to which table. You might need to select only one record from the list based on criteria such as the record with a particular approval status. You might need to specify a particular sorting order, such as alphabetical, by date, or by value. These handling instructions are crucial for the PS team to implement your requirements correctly, so they must be documented in your data model. The information must be included in the handling related list table. In our example, we want to display the table with all records, but the condition is that only those where a first line is false go into the essential items table and only those where a first line is true go into the extras table. Table summaries. Looking at our template again, we see a green highlighted sum at the bottom of each table that totals the values from the price column. We must include this in our data model, noting that it has no API name since it's calculated by the document designer. In the comments field, write present total of total price column according to the criteria of each table. Contact information for managers. Let's move to the next table in our template, which displays contact information for managers. This data structure demonstrates a more complex path. It uses a related list within a related list, plus a lookup relationship. The manager information is stored in the event assignment related list, which is nested within our opportunity products related list. The data we need comes from two places. The event assignment name and role fields are directly on the related list. The full name and email address fields require navigating through a contact lookup. When documenting this in our data model, we'll indicate this complex path from opportunity products related list to event assignment related list to contact lookup for some fields. Our requirement is to display only those staff members who have the role of manager in the generated document. To implement this filtering, we'll document it clearly in the related list handling table by specifying include only records where role equals manager. Organization of data model. We've now reviewed all the field types in our data model, from simple fields on the main object, to lookup fields, to related lists, and finally to the complex combination of related lists with lookups. Each of these requires different handling in our data model mapping. Here we can find another data model mapping table, organized by the location of the data in the template. This approach lists fields in the same sequence they appear in the document, first all fields from the header section, then all fields from the form body. Summary. The data model is essentially a translation guide that connects your template field names to their corresponding Salesforce fields. While we've demonstrated specific organization methods in this tutorial, you're free to arrange your data model in any way that works for your project, as long as all the necessary information is clearly documented. An important reminder: even when using interface wizards or shortcuts that might hide the actual data structure, always document the complete path to each field. This precise mapping ensures the PS team can correctly locate and extract the data you need. Final checklist. The PS requirements are now complete. Let's check before submission. Have you provided a test record with all the required data populated? Did you identify all fields? Did you include all API names and paths? Double-check the table and verify that all the information is present. Did you include fields used in filters or conditions? Did you include logic conditions where applicable? Did you specify formatting preferences, branding, and output format? Did you clarify how to handle multiple related records? With your complete PS requirements document, the professional services team can begin implementing your document generation solution. They will develop the initial version based on your specifications and send it to you for quality assurance review. Thank you for watching the whole series. Good luck with your project.